All right, so welcome, Luke and Matthias. Thanks for coming. I'm going to talk about how to use Python and Aivia, and we're going to have some live examples at the end about how to do this as well. So Python integration with Aivia is something I guess it's not new anymore. It's relatively new. It's an early feature right now, so it's not as comprehensive as we'd like it to be, but we think it's a really useful tool as it is. And a big part of my presentation here is not going to be just how to do it, but also why you should use it or why you could use it to make your workflow in Aivia better or easier. So for today, I'm going to talk about three different things. First, how the Python integration works. If you want to do this yourself, if you're familiar with Python and you want to integrate your own scripts, you need to know this, how it works. Next, I'm going to talk about the use cases, like I said. So why would you do this? And we're also going to talk about the anatomy of a Python recipe in Aivia. So I'm going to break down a script I have. We're not going to go over every line, but I'm going to show color-coded chunks of the script and talk about what each chunk of the script does and break it down that way. Then for the hands-on portion, we're going to load and run a few recipes. We're going to see what we can do when errors show up in our recipes. We're going to experiment with a couple of these. I'm also going to show our GitHub, which you can go to as well. And this GitHub has examples. So if you learn coding or scripting like most people, you just take a script that's already written and then tinker it and Google things until you figure it out. That's how I did a lot of what I learned and probably how a lot of people learn. And the goal here is to understand why the motivation for using Python within Aivia, more so than being able to write a script from scratch. So this presentation and the recording of it will be a useful reference going forward, but I mainly want to impress on you why we do this. So how this works. The first thing is we provide a mechanism to you, or you can think of it as an API, for you to load Aivia channels into Python. You can take those channels from Aivia then and process them with your own code. Whenever you're done, you can use a mechanism in your Python script that will take the results you get from your code and put them into a temporary file. And then at the end of the script execution, Aivia knows to load these channels appropriately back into its workspace. Okay, so what does this look like? So when you use Python with Aivia, you've got two workspaces. You've got the Aivia workspace. You can think of this as like a box. And then the Python workspace. You can think of this as like a box. So side by side, we've got Aivia and we've got a script that we've written. This is actually a real script, and this is the whole thing, so it's not too long. So the way you do this is you take your script that you've written, and you open this in Aivia as if it's a recipe. And depending on how you set up your script, Aivia will adapt to your script, and the recipe console will show different inputs you can have to Python. Okay, and then depending on how you set up these inputs here, whenever you click the Start button, a new Python workspace is created. And what happens is Aivia knows to take whichever inputs you select and pass them to the Python workspace. From there, Aivia also knows to take other parameters, like this width parameter we see in this example, and pass that to the Python workspace as a dictionary. From there, your code can utilize Aivia's channels as NumPy arrays and this dictionary as parameters to do whatever the heck you want in Python. This code can be anything. And generally, this is going to create some kind of result, an image. And then this image of your results is passed back to Aivia as a new channel. Okay, so that's the whole workflow. You write your recipe, you open it in Aivia, you set up your recipe just like any other recipe, you apply it, and then Aivia knows to take the results from that and bring them back in as a new channel or as a new object set. So that's what Aivia is doing. Why is this useful? So aside from obvious circumstances you might think of yourself, I like to use this for writing custom image analysis pipelines. So our recipes aren't always appropriate for every single task. The data that our customers collect is highly varied in signal to noise ratio, in voxel size, resolution, etc. I mean, people collect all kinds of images, and we design our recipes to be general purpose for certain tasks. But if you need to do some pre-processing or post-processing of your recipe results, you can do those steps in Python, and then just use Aivia to run your Python recipe and integrate it. One example of this might be what I call a texture simulation workflow. So here's an example of an image analysis pipeline where you take some input image like we see over here. In parallel, you can do a dilation and an erosion. And then you can subtract the results of the erosion from the dilation. And the result of this is you can think of as a texture image. So if we look at this image after doing this image processing transform, we see this resulting image. In this case, it's not too useful, but you can see areas where there's low texture and the signal is relatively homogeneous, like inside the cytoplasm of these cells. You get a low texture, a low grayscale, and then areas have a higher grayscale wherever the texture is higher. Okay, so that's one example of something we don't do in Aivia, but now you can do in Python. And I have done, and this is on the GitHub if you want to try it. This is the use case I use most often. So you can see here, we've got a certain, whenever you train a pixel classifier, you can use these different features. And Aivia will run these processes in the background to try and characterize each pixel that you're classifying to predict further in the future. But if you want more features than what we have, you can create a new channel using some Python transform and then train your pixel classifier including that channel. Excuse me. So the example I have of this here is called shape index. This is just a simple one-line function in Python that I wrapped up in a nice script. It's on the GitHub as well. And you can see it takes this original image and creates the shape index transform. And this is useful if you're looking for something like membranes. You can see in this image, these membranes, our eyes interpret these pretty consistently. But in this image, the membranes can range from dark to pretty light. There are breaks in them. Sometimes it's a double membrane. You can resolve two membranes. Sometimes it's a single membrane. So in this image alone, it's pretty hard to pick up these membranes using pixel classification by itself. But if you run this transform first, these membranes all have a very homogeneous signal. Okay, so if you include this in your pixel classification workflow, it just strengthens Aivia's resolve where those membranes are. Another instance is if you have third-party libraries you want to use. If y'all have heard of CellPose or Stardust, these are deep learning libraries they're basically pre-trained models you can use to segment cells or just blob-like objects, and they're pretty general purpose. So if you have this data set, this is something that Aivia could segment by itself, but here's an example of what happens whenever I ran the CellPose algorithm on this data set, and I did this completely with Aivia as well. This is also on the GitHub. So if you have some functionality you want to use outside of Aivia, you can bring it into Aivia with Python. Another thing I use Python for is convenience functions. If you have users or you have images yourself that have RGB images, this is just a photograph of a leaf at very high magnification. So it's encoded as RGB, for instance, and working with RGB as microscopist is kind of frustrating for a lot of us because the red, green, and blue they make sense. Those channels make sense to our eyes whenever we care about color in the world. But in microscopy, color usually means something different. It means the single channel expression of some stain, and you have multiple stains, and they come together to create a composite. But RGB is a different color space. So if you want to break this image down to just one channel, like luminance, you can do that with Python. That's a single line in Python. But Aivia has a way, or I have a script online on the GitHub to do that. So it's not averaging the red, green, blue channels together. It's a weighted average of each one that transforms RGB channels into one channel. So then training a pixel classifier or running a recipe is a lot more straightforward on the single channel than having to consider 3 channels. Finally, if this is more for advanced users, I guess, but if you have a very specific task that requires like a sub workflow, you can create small applets to run that task. So what you see here is a super pixel painter. This is a little GUI that's been created in tkinter, which is part of the Python standard library, where we pass this leaf image after converting it from RGB to luminosity. In Python, we pass it to this pop-up GUI. The user then has some tools where they can paint on it using super pixels, which makes the painting go a lot faster. And then whenever that little applet is closed, the mask that the user creates goes back to Aivia as an object set. So this is probably the most in-depth example of why this would be useful. But it makes writing these little plugins pretty simple. Finally, rapid development. So I list this on here because, if somebody comes to me and they want a pretty simple application that's just not part of Aivia, if we want to put that in Aivia itself, it has to go through a very rigorous development and QA cycle. It has to compete against the hundreds or actually literally thousands of things that we want to add to Aivia. So we have a very large workflow, a very ambitious set of features we want to add, and list of bugs we want to fix. And if you come to me and you want something for a very specific task and you're the only person that wants it, asking the development team to do that it's just not very likely it's going to happen, at least quickly. There are cases where that has happened. But Python will enable people like me, your sales rep, or Jim or Patrice, to make a tool for you very quickly and just send you a single text file, and then you can open that in Aivia and get the tool that you specifically need, and it can be very quickly done. So this is one reason that Python is so widely adopted by so many people, and this is one reason why all these softwares that are including these interpreters or these APIs use Python for this. So these are the main reasons why you would use Python. These are some useful case studies I wanted to share. Next, we'll talk about the anatomy of a recipe in Aivia. And this is more about how you build the recipe from the ground up, but really this is how you can interpret the examples we have on the GitHub to modify what we've already written for your own needs. Okay, so I'm going to break this down into a few different sections. We've got, we'll talk about the import statements. We'll talk about documentation. There's this section called metadata declaration. This is essential. You have to do this. We'll talk about that. We'll also talk about the run function. Again, this is essential, and there are some things in here you have to do. And then the real power of this run function is that inside the hollow yellow box, you can put whatever Python code you like. It can be anything. Once you use this code to get your data into Python, you can do anything with that data, and then you just have to use this code to get the data back into Aivia. But that's the run function. We'll talk about that. And then finally, we have some text down here that just calls the whole script. Aivia knows to run the script using this. Okay, so here we go. Import statements. Python, if you're not familiar with it, it uses a rich library of packages to expand its base functionality. I find a lot of biologists are much more familiar with R. So this is the same thing as R, where you've got this huge library of tools that people have written that's shared through a central repository. In Python, the central repository is PyPy, which you can access through pip or brew if you're on Mac. Some things we include by default. So NumPy is, it's not standard in the Python library, but it's the most commonly used library for working with arrays, and images are just arrays. So it follows that NumPy is extremely widely used for working with images. We include this in the Python that we ship with Aivia. Scikit-image is a library for image processing. By now, it's very mature, and it's geared more towards microscopists than other image processing libraries. So there's like OpenCV, there's a few others, but Scikit-image is the most microscopist friendly, I think. We include this one with Aivia as well. Scikit-image depends on Matplotlib and SciPy, so naturally these are also included with Aivia. And then finally, you can install whatever package you want and use that in Aivia as well. So for instance, we talked about CellPose earlier. I went through the installation process for CellPose on my computer. It wasn't trivial, but once I got it running, I could use Aivia to call CellPose, and I can pass images to CellPose from Aivia and then back into Aivia after CellPose is run. One of our developers has actually made that process a lot easier. So if you go to the CellPose or Stardist libraries on our GitHub, you don't have to worry about that installation process. We handle it for you. So a question that you might have if you're starting with Python is, how do I know which packages have which functionality? And I put here, it's a sixth sense you develop over years after a lot of Googling, and that's true. Unfortunately, I don't have a better answer for that. But another thing you can do is ask us, hey, I'm trying to do this task in Aivia. Do you know if there's Python code somebody's already written or a package I can use for it? And then we can help you out with that as well. By convention and by Python's own style guides, these import statements always go at the top of a script. I've never really seen a Python script that doesn't follow that convention. So that's why they're the first thing we talk about. Next is documentation. So I use doc strings in my Aivia recipes. That's whenever you start a block of text with triple quotes and then finish it with triple quotes. Python knows that everything in here is not code, it's just text. I use doc strings to document my recipes because it's self-contained, it's well separated. Anybody that writes Python knows to discretize this in their brain when they read it as documentation. Mainly, I use this so that my future self knows how to use and work on recipes. Also others, if others are using it. If you want to contribute to our GitHub using your own scripts, I will require that you have at least some documentation so that other Aivia users that want to, build on top of that script know what's inside it. Next is the metadata declaration. So this is the part of the script directly before the run function that we see in blue here. And these hashtagged or pounded or commented lines of text are what tells Aivia how to set up the recipe console. So like I said earlier, when you load a Python script in Aivia, it loads into the recipe console just like a recipe. And by following our templates here, it tells Aivia how to set up these input ports. So for instance, I've got an input, I've got two inputs, and I've got one output. I'll come to that in a second. So this metadata declaration is mandatory. If you try to skip over this, Aivia won't even load your recipe. So this is a part of the script that isn't Python specific. It's something you have to learn in addition to Python to use Python with Aivia. But it's absolutely necessary for you to be able to do that. It's how Aivia sets up the UI. And at least one input and one output image are required. So you have to have an input image path and an output image path in your recipe for Aivia to run the recipe. Even if you're not going to use the output image path, you have to include it in the metadata declaration. Another must is that these declarations must be on the lines directly preceding the run function. So if you put a space between the metadata declaration and the run function, it's not going to work. You need to butt these up against each other. So if we go through each one of these, I wrote a wiki page on our wiki to document all this, so that's probably a more effective way for you to learn about this in the future. But we've got a few different types of input that we can accept. One is a string. So anytime you use an input type of a string, it's going to set up this drop-down box. And it's going to either be an input or an output. Input knows that inside this drop-down box, it's going to list all the input channels that you have available. So if you have like DAPI and GFP in your image, you're going to be able to select in this either DAPI or GFP. The name is what the Python script refers to as that channel, or how the Python script refers to that channel. And then display name is what you want the UI to show here. So that's what an input or a channel selection metadata declaration looks like. Another thing you can pass are variables. So you can see my gamma variable here. Python knows to take this value and refer to it inside the script as the gamma variable. Okay. This is a type double, so it's a double precision float. I can put a display name as gamma, and then I can tell it what I want my default value to be, and then the minimum and the maximum values that are allowed to be. And then finally, if I declare an output in all caps, this is the same thing as the input, except it's called output. Aivia knows that it's going to use this as how to create new channels with the images that are returned. So after declaring the metadata, we come to the run function. And when the recipe is started, the run function is executed. So when you click that start button in Aivia, this is the function that actually runs. This run function needs to get the parameters from your GUI. So all the parameters we get from here need to be passed into the run function, and we use a dictionary to do that. So you can see in here that, for instance, my gamma value inside the run function comes from my parameters dictionary. And I tell Python to go inside the parameters dictionary, get the value for gamma, which we declare up here, and just put it inside the run function as gamma. Okay, so you're going to see this convention inside almost all of our scripts on the GitHub, maybe all of our scripts. And then unless, another thing to include at the top of this run function is reading your channel. So the channel name in Aivia, whenever you run this run function, it becomes a path to a temporary file that's used to pass that channel from Aivia to Python. And this is a path to a file on disk. So to be able to use that channel in Python, you have to read that image from that location, right? So we've got the input name is input image path. Okay, this is, in this example, our DAPI channel. And I tell Python image location is just that path. And then I further tell Python that the image data is the array you get when you use the mread function from the file at that location. So it's kind of a string of things. If you're used to Python already, this probably makes a lot of sense. If you're not used to Python, don't worry. This will make sense after you learn it, I believe. Typically, I will use the mread function from the scikit-image library that we talked about for this. You don't have to use that, but it's the simplest one to use. Next is this section where you can do whatever you want. So by this point, we have our parameters from Aivia passed into Python. We have our image channel loaded as an array in Python, and using those parameters in that array, that opens the doors to do whatever the heck you want. So this empty part of the yellow box is where your custom code goes. Okay. Ideally, you're going to create some new image after doing whatever you need to do. And at the very end, you can take that image you create and save it back to the path that you declare in the output metadata. So up here, we declare an output location. You can use msave to take your results and put them at that location. Just like using mread from scikit-image, msave works pretty well. And Aivia knows to take whatever image you save at that location and load it back into Aivia as a new channel. Okay, so whatever you put at that location, Aivia's going to try to load it. This little block at the end, you don't even really need to understand this. This is a Pythonic convention that's used in a lot of scripts where if you just run the script, it's going to call this. And you can see here we just call the run function with the parameters dictionary. You can just copy and paste this from an existing script and use it in your own. But this is what Python is actually doing whenever you click the start button in Aivia. Let me turn this off really quick. Okay. All right, so we're about to get on to Aivia Web. Just some housekeeping before. So each person is going to receive a unique link in the chat. Please only follow the link that's assigned to you to open Aivia Web. If your screen in Aivia Web is cut off, you can use this little gear icon in the top toolbar to change the resolution. Or if the Aivia screen is cut off in your browser, you can change it to 1920 by 1080. It'll work pretty well. There's going to be a part where we have to open a text file from Aivia in AppStream, so in Aivia Web. Unfortunately, Notepad is the default viewer for viewing this text file, and it totally messes up the formatting of it. So whenever we do that, I'll probably just show that text file on my screen. And then whenever we have this open, we are going to set a different option in Aivia as well. So I think Jim has put in the chat. Yes, so Jim has put in the chat both of your links. And if you're following that link, you'll see something similar to what you see on my screen. Let me go ahead and log in here. Yeah, so when you open this, if you have to choose between Aivia 9 and CyberDuck, go ahead and choose Aivia 9. And it'll say that it is taking a second, or it'll take 2 minutes. It should only take about 45 seconds to open Aivia Web. Now's a good time. If any of you have questions, go ahead and ask those. I'd be glad to help. Or if there's anything unclear about my presentation, let let me know. I can clarify some things as well. And you can unmute or you can use the chat too. So Jacob, it looks like you're just joining. I just finished the PowerPoint. You're actually joining at a pretty opportune time, I guess. We're opening Aivia Web to do the live portion of the demo now. If you look in the Teams chat, Jim Palladino just posted a link that you can follow to open your instance of Aivia Web, and then you'll see what's on my screen. It'll be loading, and you'll be able to follow along with the rest of what I'll do. Okay, so if you see on my screen, it looks like Aivia is loaded. Please let me know if something goes wrong with your link and for some reason Aivia Web isn't able to load. I think I'm the only person that's had an issue with Aivia Web during one of these calls. I don't think any of the attendees have, so that's a good thing. You should be okay. Okay, so we're going to open an image, and then I have some Python scripts loaded here already that we can play with. Let's go ahead and open the test image. So in Aivia Web, go ahead and go to the File menu and click Open. Under the Shared Data folder, or it looks like a network drive, there's a Python workshop folder. If you double click that, there will be some files in there. And then you can select the TIFF file, the only one that's in there, CVP 13-153-2, etc., and go ahead and open that. In our case, the calibration doesn't really matter, so just go ahead and click Apply if you see the calibration window. And you'll see a histology slide show up in Aivia. Please let me know if that's unavailable or if for some reason you don't see this. Something I just habitually do right now is whenever I open an image, I like to go ahead and close this bottom panel. So if you hover your mouse over the divider between the thumbnail view and the viewer, you can just click the single solid blue line when it shows up, and that'll collapse. That gives you more screen real estate for your image. And we see here, this is, I believe, a hair follicle. No, it's not a hair follicle. I forget exactly what structure this is, but it's in porcine skin. And you can actually see these very dense objects in the middle of it are silver nanoparticle agglomerates. But this is a histology image. It's been stained. I forget exactly which stain I used for this. It's been so long. But what we see here is a transmission light microscopy image. And like I was talking about before, the stain here is represented with red, green, and blue channels combined. So we're going to go through the convenience function that I was talking about before. In this case, if we wanted to do segmentation, for instance, on these cells in this image, we have a few choices. If you just want to use a recipe in Aivia to segment the cells, you first have to choose which channel you want to segment. You can't just do it on an RGB image. So you have to cycle through the red, green, and blue and see which channel best shows the cells. So right off the bat, working with this RGB image is not ideal. It's got a lot of entropy to the workflow, and I have to make this decision right off the bat. And I don't really know. It depends on the stain, depends on the imaging conditions. It depends on whether it's been background corrected, which of these channels is best to work with. Another option is to train a pixel classifier and to train the pixel classifier on all the images. And that way the pixel classifier will essentially see RGB space. But then the pixel classifier takes 3 times as long to run because it's trying to train on 3 different channels. And every image you have in the future, the RGB all have to be the same to reapply that classifier. So again, it would be a lot better if we could just basically work on one channel that is representative of how our eye interprets the image. So this is why a luminosity transform would be very helpful for this kind of image. There's a Python script for that. You might have seen it whenever we open the data. So the way to access that Python script in Aivia is like this. In the right-hand panel where it says Analysis Tools in the Recipe Console, next to the Recipe dropdown, there's an Open button. It looks like a little folder. And if you click that button, you might need to navigate back to the shared data in Python workshop folder. It should already be open since you open the image from there. There's an RGB to luminance file. And that's a Python file. You can just double click that RGB to luminance. And when you do, you see the recipe console actually has that RGB to luminance.py selected in the dropdown. And you can come down here and click the input and output and expand that. And you see there are some options there. So this script has 3 input channels it requires, and I've labeled these green channel, blue channel, and red channel. It has an optional parameter called show histogram, and I put in the text string here. If you don't want to show a histogram at some point, you can click, you can leave it at 0. If you do want to show it, you can put 1. And then luminance is the channel that's going to be created upon execution of the recipe. Let me go ahead and just show you what this looks like. So just like before, in this Python script, we have the import functions at the top. I've got this document string or doc string that describes, what these channels are, what the histogram means, etc. Let me make this smaller. So Aivia knows to set up this recipe console with the green channel first, and that comes from this line in the metadata declaration. You can see here I've declared an input, and the display name is green channel. I've done the same for a blue channel and a red channel. So Aivia knows to create these 3 channel selection inputs whenever it runs the recipe. The histogram input is also listed here, but you can see here the display name actually shows the text that shows up here. So that's how you can correlate those. And then finally, I'm telling Aivia the output, the display name is luminance. And since it's a string, just like these other 3 channel selection objects, it's looking for a channel to create, or it's looking for a channel in the channel list to output our result to. You can see by default, since it's output, I can create a new channel. if I wanted to, I could overwrite a previous channel as well. Not to get too into the nitty gritty, but I'll go through this flow really quickly. Let's say for the green channel, since that's the first one up here, Aivia knows to take the path to this green channel that we select and assign it in the dictionary with the keyword of green_C. Okay, so whenever I run this run function, or whenever I run this script and the run function execute, it's doing it with the params dictionary, which is where Aivia includes the path to the green channel, or this green_C. So you can see here inside the run function, I can access where that green channel is stored on disk using this dictionary keyword accession assignment here. So after I save this as just plain green C, then later in the script, I can read that channel, or I can read that path using mread to a variable called green data. And then I can use that green data, that array, throughout the script. So here I calculate gray data from a combination of the red data, green data, and blue data. To run this, it's pretty simple. You use it just like any other recipe. So I can choose green for my green channel, blue for my blue channel. And it's a neat little trick. If you want to show a histogram after you can calculate luminosity, you can set this show histogram to 1. And whenever you do that, you can click the start button. So you can see during the script, I actually show a figure. This is the luminosity histogram. You can see that Aivia has already created a luminance channel. And after the processing is complete, you can click just in the middle of that luminance channel. And now we see a grayscale representation of the data. So now we have a single channel to work with if we want to do something like segment these nuclei. So I'm happy to pause and cover any of that again if any of you need me to. I'm going to go ahead and continue in the meantime. But if you do need me to go back, please let me know in the chat and I'll be happy to stop and do that. For the next script, I want to cover something else. So before we do that, if you want to write your own scripts, you need to be able to debug them. And there's a way in Aivia you need to do that. So if you go up to the File menu in Aivia again and go to Options, under the Logging tab, you can choose this verbosity dropdown. If you're writing a Python script, I recommend you always just choose everything. So this means that we're just going to log everything. Every error, every warning, every piece of information that Aivia wants to report is going to show up, in this text file. So go ahead and click Apply. So next, let's load a script and assume we have a bug in it. So if you go to this open folder for the recipes where we opened the luminance recipe before, there's a file called adjust_gamma_demo_bug. Go ahead and double click that and open that recipe, and then expand the input and output section. So spoiler alert, this recipe has a bug in it. But whenever we're developing a recipe, the whole point of a bug is we don't know what's going to happen. So let's just apply this recipe as if we didn't know there was a bug. So for our input, we might want to run a gamma adjustment on this luminance channel. So I can choose for my input image, my luminance channel. A good gamma might be like 0.75. And then whenever we come down here and click start to run the recipe, Aivia will tell us error encountered down here. So if there's a bug that interrupts the ability of Python to complete the script, Aivia just says error encountered. Well, that's kind of maddening because what error was encountered? How can we fix it? So you may have guessed that that error is shown in the Aivia log. So if you want to look at the Aivia log, you can again go back to File, Options, under Logging, where this log file is, you can just click the Open button. And if I scroll down, so if you're following this on your computer or if you just want to look at my screen, Notepad is just so bad at opening some ways that text is encoded. So actually in Aivia Web, this note or this log file is very difficult to read. On your own computer, I recommend using something like Notepad++ that will properly parse this file. In that case, this log file will look like you see on my screen, and you will see a bunch of lines that start with Python. That means that Aivia is reporting an error from Python. So this tells me that in line 45 of my script, where I've got, where is it? So it's line 45 and run. If I follow this error down to the end, it's showing me that in line 413, I've got an error here where this operand is not supported between string and int, which tells me that either one of these values, gamma or 0, they're different types. So if you're developing Python yourself, you'll be familiar with what this means. But this means I can go back to my script, find where that error is, and then fix it. So this is how you debug scripts using Aivia. Whenever you do fix it, you can simulate fixing it yourself right now by opening another recipe. So if you click this Open folder in Aivia Web, or Open File button in the recipe panel in Aivia Web, now you can load a JustGamma demo without the underscore bug. And then do the same procedure before, where we tell it, I want my input image to be the luminance. I want to use a gamma of 0.75. And then instead of creating a new channel, you already see that there's a gamma adjusted channel. We can just go ahead and overwrite that one. And then click the Start button. And now whenever we click the gamma adjusted channel, we see that that process has been applied. That's actually, I used a very bad value for that. Actually use 0.25 instead of 0.75 and reapply, and then turn that channel on and off, and it should be a little better. But you can see here the process is running. I'm bad at parameterizing it, but it's running correctly because you can see the difference on my screen, at least, between the histograms before and after the script runs. So that's an example of a convenience function, an image transform. I've showed how you can use Aivia's log to debug your scripts, and we didn't actually go and fix that script. I did that before. but you can see how you can trace errors. Whenever you're working on your own script, those error messages are going to make a lot more sense because you're in that headspace of, you remember the line of code that shows up there, and then you know exactly where to go and what could be wrong because your brain is involved in that task. Whenever you see somebody else's error code show up on the screen, it doesn't always make sense. But those are two simple examples of Python scripts. I have one more. So earlier we saw that shape index. If you want to play with that, you can go to the open button again. Double click the shape index file. And then for this one, I recommend for the input image, use the luminance channel again. Gaussian sigma, maybe just use 2. And then the shape index, the output, we can create a new channel and click start. And then now on my screen, if you see, I can click the luminance channel and it will again show the luminance image. And I can just click the middle of the shape index channel that's created and it will show a very different looking image. And I can click back and forth between those. But if I'm interested in these cells, this process might help because if you look closely, these nuclei are not constant in signal, but in the shape index image, they're almost all very constant in signal. Okay. And like I said before, the reason to use something like this dramatic image transform might be because if you see on my screen, I can go to the pixel classifier now. And whenever I train my pixel classifier, I can use that new channel as input to the pixel classifier. So if I were to try to segment these nuclei, I would train on both the luminance channel and the shape index channel. And between those two, I might be more likely to get a good segmentation out because I've just got more information to use for my machine learning input. All right, so do I have any questions from y'all so far? Does this make sense, or depending on your Python level so far, maybe it doesn't, maybe it's too in the weeds or not in the weeds enough?
For me, it's clear. Thank you.
Okay, great.
Yeah, it's
great. Thank you.
Good deal. Thank you. Okay. If you want to see one more trick or one more example, maybe let's do this. Let's go up to the view menu, and inside the view menu, there's an ROI tool. You can click that and nothing appears to happen, but now whenever you use the left mouse button to click and drag on the image, it'll create a box. Okay, so if you have a nice, I made a small box around this central area where we've got this strange shape. You can make a box and then right click it inside that box and say crop ROI. And this is just a nice tool on its own, even outside the context of Python. Oops, I did copy ROI, do crop ROI at the bottom. So if we focus on this middle structure, I've tried using the pixel classifier on this middle structure, and it does okay, but picking up all of it is kind of difficult. I found that a super pixel painter worked pretty well for it. So if you want to play with an example of that applet that shows up for that dedicated task, you can go back to the recipe console, click the open button, and then double click the super pixel painter script. And for this script, it's parameterless, at least here. All I have to do is choose the input image. I'm going to go ahead and choose the luminance image again. And click the start button. And you should have a little pop-up show up in the middle of your screen. If you don't see the pop-up, you might need to click the button I'm showing in AppStream right now to bring up all the windows on the screen and then choose this one. So this little pop-up, it has some sliders here on the left. I can change the number of markers. And I can change what's called the compactness. Actually, if you drag that compactness all the way up to like 0.001, it should be a lot better. So in the background, I'm using Python to first create this little pop-up window, right? I'm using Python to handle all the clicks that I'm doing in the pop-up window. And I'm computing and overlaying what's called superpixels on the image. So this is just, you know, if the image or if pixels were to be grouped together with their nearest most like neighbors, it would look like this. It almost looks like you know, whenever you see congressional districts that have been gerrymandered, it looks like that, right? It's got these little squiggly lines everywhere. Using the left mouse button, you can drag over these superpixels. And now I can segment this image without having to explicitly click every single pixel. Every time my mouse moves into one of the superpixels, it highlights the entire superpixel. So in this case, we're using Python to take a very tedious process, manual segmentation, and speed it up and make it a lot easier and a lot more ergonomic. And you can kind of play around with this. If you make a mistake, you can actually drag the right mouse button to erase superpixels from this mask. But you don't have to do anything super fancy. Just get a few of these segmented. You can see here, I've actually got a closed contour and I can middle click to fill that contour. And whenever you have a nice little mask made, go ahead and close out of this window. And you'll see that your paintings have been put back into Aivia as an actual segmentation. So we also provide a way for you to take an output image, and instead of making it a channel, which we have also done here, you can tell Aivia to go ahead and run the segmentation engine on that image and put what you segment back as a segmentation. So now I've got outlines here, and automatically I can go click my spreadsheet and I can see that I can make some measurements on these outlines. So like area or whatever. So in this case, not only have you added some internal or seemingly internal functionality to Aivia, you've also added an external UI where if you want to expose a very specific workflow to your users or to other people, you can create a little pop-up wizard that does it for you. And then the results can just go right back into Aivia. And by passing the image back into Aivia cleverly, we can then use all of Aivia's tools on that result, just like you would a native Aivia segmentation. So hopefully that little script worked for everybody and you found it neat. So we're a little bit early, but that's what I had planned for you today. So I showed you why you would use Python with Aivia, how you can do it, and then I also showed you some examples. If you want to see any of these examples moving forward, I'll copy and paste a link to our Python distribution into the chat here, or sorry, our Python GitHub into the chat. So you can go to this GitHub, and we have some information here about Python just in general, but you can also click into a few things. So there's recipes folder, and these are all .py. All these .py files are recipes written for Aivia. You can load them into Aivia and run them for your own purposes. And everything you've seen here is already in here today. We have recipes that require very specific computing environments as well. And these are things that if you just load them in Aivia and you don't take necessary steps to install the right Python environment, it's probably not going to run correctly. So if you go to this VENV, the virtual environment recipes, you'll see installations for how to get Cellpose and Stardist running inside Aivia here. And actually, one of our developers has taken something very difficult to do, which is passing around Python environments, and he's made it very easy. So you basically download this entire virtual environment, and then the result is you have one file you drag into Aivia, and it can run Cellpose or it can run Stardist. So there's some neat tools you can play around with here. Something we have been doing lately is releasing quick tips for both Python and ImageJ. There's a few of those in our Python quick tips repository as well. These are Python tips that are going to help you anywhere. It doesn't just have to be in Aivia, but in any of your Python scripting. And with that, if any of you have any questions, I'm glad to take them. Otherwise, that concludes what I wanted to show you. And thank you for coming, and I appreciate you being here.